Hello and welcome back. In this video, we will be calculating the optimized buffer size for our SSIS package. So, in order to do that, uh, first we will go into SQL Server, run this command on our uh, table, and copy these data from here to Excel. And here it is the same record which we see by running this query on the table. So our optimized buffer size, let me first tell you each term. So this is the data size, this is the number of rows in kilobytes. Default max buffer rows within the one basket should be 100 MB. If we select 2 million rows and their size is exceeding 100 MB, that will automatically will be shifted to the next basket. So minimum this is the size for rows. It cannot exceed 100 MB. Okay, understood? Now this is the buffer size. This is, you can say, a memory size in which SSIS is processing. So this can be minimum of 10 MB and maximum up to almost 2 raised to power 31. What will be the value, and then minus 1 from there. This will be the maximum allowable buffer size, which is here, this one. And this is the number of rows. So next we will calculate this formula, row size per row. This will be in bytes. What we will do, we will get the value of data from here, which we get from SQL, divide it with the number of rows, and multiply it with 1024 to convert it into bytes. That will be 56.9 bytes per row. Then we will move here into this formula, buffer rows. We are calculating the number of rows in one buffer. So that will be buffer size. Currently we are calculating buffer size. That is buffer size. So formula is buffer rows is equal to buffer size divided by row size. So we need to calculate buffer size. We will write buffer size here, and buffer rows will be multiplied with row size. So how you determine the buffer rows? Buffer rows can be determined by, there is a rule of thumb like maximum of 1 million rows inside one basket. So if you plug 1 million multiply by this row size 560.9, you will get, this will be your optimum buffer size. But this can be done other way. So now what we will do to check whether we are doing okay, we will run the package with default values and note the time, which is 10,000 buffer rows. So that will be 1.187 seconds. Sorry. Default is 1.187 seconds. Now what we will do, we will keep the buffer rows same, but we will change, we will put this minimum size for buffer inside a Visual Studio and see what will happen. This is the minimum we can put. We'll stop it and run it again. This time it's 1.187. So this one is same. Minimum buffer. Minimum buffer. Then now we will put the maximum buffer size. And guess what? We will have a same. Oh, there is a fact. And we have 1.157. 1.157 maximum. Maximum buffer size. Now let's try to change the number of rows. Let's increase the number of rows to 100,000, and buffer size we will keep it as default 1048576. That this is a default value. See, our time is now 0.828. 0.828 rows 100,000. Now what we will do, we will increase the number of rows to 1 million and put the buffer size we calculated. That will be 56903,432, and increase the number of rows to 1 million. Uh, uh, Stop the package and run it. This time it is 0.890. 0.890. So this is the optimum value for our program. Currently with 1 million rows and we are getting 0.82, and here we are getting 0.89, which is only 0.6 milliseconds uh, less. But if the number of rows increases and we will keep it to 1 lakh, then this value will no longer hold. Currently we are using only two buffers. So that's all. And one other thing affecting the buffer size is uh, this we calculation will be the same, but these timings will differ. So you need to check for this will be a hit and trial a bit to check for the optimal buffer size. But this is you can say my method of doing calculating or optimizing the buffer size. But you can do it completely in another way. One method which I have Also, sometime I work is I will calculate the number of rows by keeping the buffer size to default. uh, if I divide these two values, sorry, default one is not this one. Default is 104857600. So 1.842728 should be the rows. Let's check. Sometime I use this method also. Uh, 1842729, and this one will be the default is 104857600. So if we run the package, let's see what time we will get. This time we are down to 0.859. So these two methods work seamlessly fine, but the thing is we are using the same formula. First, we are calculating the buffer size and keeping the rows to 1 million. Uh, just multiplying buffer rows, 1 million multiply the row size and calculating the buffer size. This way using we are keeping constant the buffer size, and that and then calculating the number of rows. So they two both are equally identical in some way, but for each package and what kind of components you are using in SSIS, these things all affect the performance of your package or the time it took to execute. Currently, we are only getting uh, a memory optimization or time optimization of only 4.4 seconds, but these are only 100,000 rows. So if the number of rows will be in billions and the data will be in terabytes, then this point 4 will translate into maybe in hours or more than 100 or 200 minutes of optimization. So this concept is very important for everyone who wants to work in SSIS. One other thing sometime I use during working is uh, I ran I ran the package multiple times with different values, and I populate them by changing rows and buffer size, and then I populate it with inside the Excel with respect to the time and calculate the time for each package. This can be done for small packages, but for big packages which already taking more than 40 minutes or 25 minutes, this technique become infeasible. But the package who are running less than 15 minutes, we can do this technique. So what I do, I will change these two values and record all the values inside the Excel, and there will be a table, and then inside the table I will go and find the correlation, like what is the correlation between the time and the buffer size and number of rows. So if you know the concept of correlation, then it's good. Otherwise, there will be a strong correlation if the time is increasing by increasing the buffer size, and the correlation coefficient is approaching 1. Then there is strong correlation that we need to reduce the buffer size. but to what value, that this is all depend on the experiment. I always find this formula much better handling in large SSIS projects. Thank you very much. Hope you understand, and bye.